In this lecture, we're going to solve another question relating moles to redox reactions. So in this question, there's an experiment going on where a metallic salt is reacted exactly with, it's getting reacted with sodium sulfide. And the half equation for sodium sulfide ion or oxidation of sulfide ion is given. So he's done half of the question is solved already because the oxidation of sulfide ion is getting oxidized. So he's given us the reaction and it's losing electrons. So sulfide is losing electrons. So we know what our reduction equation for oxidation is. So this is the equation for oxidation. Now we only need to figure out which thing is getting reduced. Now if you look at this reaction, there's a metallic salt that's reacting. That means that if sulfide is getting oxidized, then that metallic salt must be getting reduced. So I don't know what the exact equation is, but I do know that the metallic salt, let's call that metallic salt M, is going to be gaining electrons because that's the only other reactant in the equation, and I don't know how many electrons, so let's call that N electrons. And he's given us one thing. He's told us that if the original oxidation number of the metal in the salt is +3, so that means that the metallic salt, whatever the metal in the salt, that metal would have an original charge would be +3. So that is gaining electrons, and I don't know how many electrons it's gaining. So I've written N electrons, and I don't know what the final charge is going to be. Let's put a question mark over there. I don't know how many electrons it's gaining, so I don't know what the final charge on this metallic salt M, which has a charge of +3, is going to be. But I've come up with a reduction equation. So one thing is getting oxidized, which is sulfide, losing electrons, and the other thing is getting reduced and it is gaining electrons. Now the next thing I need to do is I need to find the moles of sulfide, and what I've been given is the volume and the concentration of aqueous sodium sulfide. So the sulfide of moles, the moles of sulfide would be exactly the same. So the volume is given, the concentration is given, so I can find the moles using the formula moles is equal to concentration into volume. So if I use that formula, the concentration that's given is 0.1 mole per dm cube. And the volume that's given is 25 cm cube. That should be in dm cube. So I'm going to divide that by 1000. And the answer that I'm going to get is 2.5 into 10 raised to the power minus 3 moles. So this is the moles of sulfide that are given to me. So I'm going to put those in the equation. So moles of sulfide, that's 2.5 into 10 raised to the power minus 3 moles. Now using ratios, one sulfide produces 2 electrons. That means the amount of electrons is double the amount of sulfide ions. So 1:2. So 2.5 into 10 to the power minus 3 moles would produce, it's going to produce 5 into 10 raised to the power minus 3 moles of electrons. So I've figured out the moles of electrons that are being produced in this oxidation half equation. Now from the question, another information that's given is the volume and the concentration of the solution of the metallic salt is also given. So I can find the moles of this metallic salt M using the formula again, moles is equal to concentration into volume, and the concentration that's given is 0.10 and the volume that's given is 50 cm cube, and that should be in dm cube. So I'm going to divide that by 1000, and the answer that I'm going to get is 5 into 10 raised to the power minus 3 moles. So using my calculator, that's the answer that I'm going to get. So the moles of metallic salt are given to me, and so that means the moles of the metallic salt M, and the charge which was already previously given to us, that that the ion of the metal in the salt was +3. So that's already given. So it's 5 into 10 to the power minus 3 moles. So this is the information that I've been able to extract. Now coming back to the original question of trying to figure out what the charge on this salt is, on the metal in the salt is after reduction. As you can see, sulfide had 2.5 into 10 to the power minus 3 moles. So the amount of electrons that it was producing was 5 into 10 to the power minus 3 moles, because it's 1 produces 2, so it's 1:2. So 2.5 into 10 to the power minus 3 moles would produce 5 into 10 to the power minus 3 moles. And according to redox reaction, the amount of electrons that are being produced, it's the same amount that would be gained. So that means that the amount of electrons that are being gained are exactly the same. So that's going to be 5 into 10 raised to the power minus 3 moles of electrons. Now, based on the ratio, and look at this reduction equation. I have 5 into 10 to the power minus 3 moles of M plus 3 ions, and I have 5 into 10 to the power minus 3 moles of electrons. So that means that the ratio of M plus 3 and electron, the ratio is 1:1. So now I know the value of N, which is basically 1. So I can rub that off. So that means that M plus 3, 1 M plus 3 is basically gaining just 1 electron. So if M plus 3 gains 1 electron, it would become M plus 2. So now I've figured out the charge, the final charge on the metal in the salt. So it's going to be M plus 2, and the answer is going to be, it's going to be option number B.